Right, so thanks everyone. My name is Ken. I come here all the way from Ottawa, Canada. And I'm going to hit on three things today as part of kind of a future-looking talk. Maybe a bit of the future, maybe a bit of the present. Bit on the rise of platform engineering. We heard Francesco did a great job this morning kind of highlighting the benefits of platform engineering. It's why you're all here. And a little bit on why API management tools need to evolve to kind of embrace that trend. And then to dive a little more deeply into accelerating dev loops. So I'm VP of Engineering at Ambassador. Once again, came from Ottawa, which used to be referred to as Silicon Valley North. Before Ambassador, I used to be at Puppet and Cloudsmith. So at Ambassador, we develop tools that dramatically improve the developer experience. Deep roots in open source and cloud native, and more recently, in fact, just last week, we launched a new product to help developers with API development. So I'm a strong proponent of DevOps. Worked with Puppet, which was seen as one of the pioneers of DevOps. A lot of great practices, really revolutionized software development. My personal mantra is always be shipping, measure what matters, and fail for the win. So great practices, but over time, as things became a little more complex and we saw people adopt these practices in individual teams, some problems have emerged, right? There's too little automation. Even despite the great practices that DevOps brings, there's still a fair amount of manual intervention and repetitive tasks that take place. DevOps brought a whole slew of tools that are specialized for a bunch of different tasks, and so there's just a huge ecosystem of tools with a lot of complication that brings. And then as each of these practices were adopted and employed in individual teams, you end up with differences between these different teams. So organizations have struggled a little bit to have kind of a cohesive approach to how they deploy software. So enter platform engineering. Platform engineering originated in the notion that we should take a lot of these practices and embed them into a shared platform. We want to provide developers with simple, scalable, user-friendly, self-service processes to build their software. So with shared, streamlined processes, you get some more consistency. By introducing a little more automation, you can avoid some of the manual interventions that are needed. Self-service allows developers to become a little more self-sufficient and more efficient to avoid having to necessarily wait on their ops colleagues to get their work done. This streamlining and this self-service results in accelerated time to market. And this kind of shared platform brings a consistent way to approach scalability and avoid failures. And because there's a shared platform that all your teams are using, you can enjoy better collaboration because things are the same, they're working on the same platform, and they're sharing same practices, doing things in similar ways. So in a lot of ways, it's easier to collaborate. So why should we care? So platform engineering sounds great at an organization level. But I think there's a danger here. And in addition to being passionate about DevOps, I'm a huge fan of Agile. And those of you that remember the Agile manifesto from years back, the number one value was individuals and interactions over processes and tools. So the shift of focus to a shared platform, there's a little bit of a danger there that you over-rotate and you focus too much on the tooling and you ignore the people involved. So we should all care very much about what's happening, and we should be pushing for what really should be prioritized as part of the shift to platform engineering, and that's the developer experience, right? It's all about helping empower developers to perform their best work. So you really want an enhanced developer experience. You want those interactions that your developers are having with the tools to be a quality experience. You want to streamline operations and resources. You want to give your developers access to the resources they need. And hopefully you avoid some of the commonality patterns that could get in the way of an individual developer from doing their day-to-day work. So that's platform engineering. So how do API management tools need to evolve to support and embrace this trend of having platform engineering and a solid platform? So first of all, I think they have to embrace the key strategic practices that the business is trying to achieve as part of this. In order to have a successful platform, you really need to focus on those developer needs, right? What is the developer's experience and what are their needs? And are you doing enough to meet those individual needs? Versioning challenges are real, maybe not early on in the life cycle of a project, but certainly as a project evolves, versioning becomes a real problem. So you need to tackle those versioning complications, have a good strategy from the beginning. Early on, a project isn't that large, but it will grow and scale over time. So you really need to invest in scalability as part of your platform approach. You need to have security and compliance support. Those are real things in a real organization. So you need to make sure that you're able to support conformance and regulation mandates. And ideally, the platform would have a way to intrinsically demonstrate the value that it brings, right? It may be not lost on you if you're building the platform or using the platform, but sometimes it's hard to communicate the value that you're getting from the platform. So ideally, the platform would provide built-in mechanisms to help showcase and promote the value that you're getting. You have to put developers first, right? So in order to embrace this platform engineering initiative, API management tools really need to put developers in the driver's seat. And they need to be tailored to the complexities and the realities of modern day development, right? And so they need to support enforcement of policies in a flexible way so they don't become too onerous on a developer. They need to be highly customizable so that they can be tailored to the specific needs of the problem set that a developer is working on. They need flexible and customizable security features to meet the needs of modern day security problems. We've heard a lot about security problems here at the conference already. They need to be able to scale as the organization grows so they can handle larger and larger loads without loss of performance. And of course, observability, right? You need insight into what's happening. You need monitoring and analytics to be able to make sound decisions. But if you think about the developer, if you're putting them first, what's it really all about? So to me, the most important thing is focusing on that day-to-day life of a developer. What is the developer interacting with? What are they doing on a day-to-day basis? And I like to think of that activity as the strange loops of developer experience. So a developer is working through a couple of development loops. The inner development loop is really all about what they're doing on their local workstation. It's that process of coding up a change, building it, trying it out locally, debugging it, maybe finding a problem, tweaking the code, building it. It's that iteration very rapidly on a local workstation, but that's happening in the context of their teammates and the broader organization where you're planning changes. When a developer submits a change, you want to do peer reviews and then merge those changes, integrate them with other changes that have emerged, do some integration testing, maybe deployment to a test environment where you can do some more advanced testing, and then maybe deployment into a staging environment, and then later on production, where you will monitor the changes, see how they're working in practice, and that will drive additional changes that you plan. So if you think about a given change and the life cycle it goes through to get into production, you can imagine planning to do the change and having an individual developer iterating through a number of passes through this inner dev loop in their local environment, submitting the change, and now the change goes through that outer dev loop where you're doing integration, testing, and deployment, and eventually getting into production. So a given change through its life cycle might go through several iterations of this inner loop, and hopefully only one iteration of the outer loop, but oftentimes you find problems during integration. Integration tests fail, or you find a problem when it's deployed to your staging or maybe even your production environment, and you have to go back to the drawing board and iterate again through the inner loop. So a given change is going to go through several cycles of these loops. And so to me, the most important thing in introducing the platform engineering approach and tailoring our API management tools for developers is to really focus on optimizing these development loops. So how do you go about optimizing the dev loops, right? So to me, it's all about less being more. You want to streamline, automate, remove as many steps as possible. You want that inner loop to be as small and as rapid as possible. And ideally, you want to bring some activities from the outer loop to the inner loop to avoid having to go through those things multiple times when you find problems. So it's really all about giving that developer faster feedback locally as they're doing iterations to the inner loop. You want your developers to use tools that are familiar to them and they're comfortable with, but you want to give them access to remote resources and environments as part of their local development, so they can get a good sense for whether the changes they're developing locally are going to work when combined with things that are running remotely. And having that hybrid set up with local and remote means maybe you can consolidate and reduce the number of remote environments that you need, thereby reducing resource usage and reducing your costs. And ideally, if you're combining this local and remote, you have an opportunity to collaborate with your peers while you're developing locally, right? So you're kind of bridging that gap between individual local development and shared outer loop activities, and collaborating, getting some of those benefits a lot earlier in the life cycle of a change. So for me, the future is faster, better development loops, which give you faster and better API development. So here's some examples of things that tools can do to dramatically improve that development loop lifecycle. So finding ways to automate some of the steps that need to happen as part of that inner loop. For example, helping you design specs with AI. There, I said it, AI. But helping using AI to automate some of the menial, tedious types of things, giving a developer a leg up, instead of them having to bang out an open API spec by hand. Use AI to help you do that quickly and efficiently. Help the developer avoid writing boilerplate code, right? If they have to write CRUD type operations again and again, that's a repetitive task that these days a developer shouldn't have to do by hand. We should be able to leverage automation to do that kind of thing. They give them a leg up and help them focus on the interesting code, right? The complex business logic where the real value lies. If you've got an API that you've designed and you want to collaborate, having a shared mock that your back-end developer can develop against and your front-end developer can develop against at the same time. And as that spec is changing, as the API is changing, the mock is updated in a shared place so that both of those developers can work against the same source of truth and effectively collaborate on that API as it's being developed and as the implementation takes shape. Finding ways to run and debug code collaboratively. And so instead of just debugging and testing changes locally in the absence of anything else that's happening, finding ways to collaborate with your peers, have your front end and your back end developer work together on testing out an implementation. So tools that can support this bridging the local to the remote and collaboration between different people in the organization as the code is being written a lot earlier in the code lifecycle. And then finding ways to deploy and integration test your code before you merge the changes. So again, having a more of a hybrid setup where your local changes, your local environment can be integrated and tested against your remote target and other services in that target environment, allowing you to debug and make changes before you even put up your pull request or your merge request, and before even the kind of official peer review needs to happen as part of that outer dev loop. So I'll leave you with that. I have to say that I've seen the future. I mentioned we launched a product last week that does a lot of these things, and we think is a really compelling way to improve the developer experience when developing APIs. No matter which tools you choose, no matter what your platform looks like, I think the important aspect in my mind really is to focus on those strange dev loops, right? So accelerating the inner dev loop and the outer dev loop. I've seen it happen. We've built what we think is a great tool to help support that. If you want to learn more, you can check out the link or find me here at the conference. I'm here all day, and I have some cool stickers to give out as well, in addition to the socks that you all received in your conference tote. And thank you very much for your time.